let's work a couple example problems so you guys know how to go through these on the worksheet. There are three equations that you're going to need to know in order to calculate kinetic, potential, and mechanical energy. The first one is the equation for kinetic energy. Kinetic energy is equal to 1/2 mass times velocity squared. The next equation you'll have to know is that gravitational potential energy, which we usually just abbreviate PE, is given by mass times the acceleration due to gravity times height. And finally, the last equation is mechanical energy is kinetic energy plus potential energy. So let's go ahead and take a look at this problem. Find the kinetic energy of a ½ kilogram ball moving at 12 meters per second. As always, I expect to see work, and that means show me what you know. So the first thing it gives us is a 0.5 kilogram. That's a mass. Moving at a velocity of 12 meters per second, and we're supposed to find kinetic energy. So there's the two things I know, and the one thing I want to know. Kinetic energy is half mass times velocity squared. So I'm going to take, let's see, 1/2 of 0.5 times 12 squared. Well, half of a half is a quarter, and 12 squared is 144, so this is 36 joules. Now, before I move on to the next problem, let's take another look at this problem, but let's say that instead of telling me how fast it's moving, let's say that the ball has 26 joules of energy. How fast is it going? Okay. Well, we're going to use the same ball, so the mass is still 0.5. The energy is 26 joules. And we're supposed to figure out how fast. So now the velocity is unknown. Same equation, kinetic energy equals half mass times velocity squared, but we have to solve it for v, and that gets a little bit tricky. So let's put in what we know. 26 equals 1/2 times 0.5, which times v squared. Well, again, 26 equals half of v squared, or half of 0.5, which is 1/4 v squared. I'm going to multiply both sides by 4 to get rid of that fraction, and I get 104 for v squared. Now, to actually find v, I'm going to solve by square rooting both sides, and v equals the square root of 104, which is just a little bit bigger than 10, about 10.2 meters per second. Okay? So if you have to find the velocity when you're given the kinetic energy, you can do that, but you do have to remember your order of operations. So first I did the half mass, which got me my quarter. Then I multiplied both sides by 4 because that cancels that with that, and then I was actually able to get my velocity. Alright, let's take a look at another problem. Find the potential energy of a 4 kilogram book that's 1.2 meters high. So again, mass is given, m equals 4 kilograms. Height is also given, 1.2 meters. And g is something you should just know. On Earth, the acceleration due to gravity is 9.8 meters per second per second. We're asked to find potential energy. Well, potential energy is mgh, and so I'm going to take 4 times 9.8 times 1.2. And if I do that, I get 47.04 joules. Okay? Again, not a difficult problem. And just like before, you can use this to solve for anything. So if instead I said, how high is the book if it has 98 joules of energy? Well, then we would say potential energy is 98 joules. Mass is still 4 kilograms. G is still 9.8. And we're asked to find H. So 98 equals 4 times 9.8 times H. And I don't know H. I'm going to divide both sides by 9.8, and I get 10 equals, 98 divided by 9.8. Yeah, 10 equals 4H. And if I divide both sides by 4, then H equals 2.5 meters, which makes sense. It's got a little bit more energy, so it needs to be a little bit higher. In fact, it's got a little bit more than twice as much energy, so it should be a little bit more than twice as high. Finally, let's look at one problem that combines them both. Determine the mechanical energy of a 6 kilogram model roller coaster moving at 2 meters per second when it's 1.5 meters above the ground. Well, mechanical energy is potential energy plus kinetic energy. So I'm going to find them both. So I know the mass, 6 kilograms. I know the velocity, 2 meters per second. I know the height, 1.5 meters. Kinetic energy is half mass times velocity squared. So I have 1/2 of 6 times 2 squared, which half of 6 is 3, 2 squared is 4, so this is 12 joules. 12 joules of kinetic energy. Potential energy, mgh, so 6 times 9.8 times 1.5, and that's 88.2. So if we add those up, mechanical energy is 88.2 plus 12, which equals 100.2 joules. Not too bad.